Hi, my name is Michelle, and welcome to Visualizing Your Data with SG Procedures. To get started, let's jump right into a scenario. You are now seeing my SAS Studio session. I've opened the baseball dataset that is in the SAS Help library. SAS provides these SAS Help datasets for you to use for examples and for testing code. The baseball dataset contains salary and performance information for baseball players who played at least one game in both the 1986 and 87 seasons. As I look at this data, I am interested in determining which team was better for given baseball stats for the given time period. Looking at the data, we first see a column called Name, which represents the baseball player name. Then we have a team column. Then we have numerous stats, such as the number of times at bat, number of hits, number of home runs, number of runs, and so on. We want to see which team was better from the perspective of number of runs and number of home runs. In this program, I have a proc mean step highlighted. This step is using the dataset of SAS Help Period Baseball. We are grouping the data by team, doing an analysis on the number of runs and the number of home runs, summing up those two numeric columns. This proc mean step produces this report. What I see is a table. The first column shows me the team name. In the far right column, I can see the sum of two numbers. The first number represents the number of runs. The second number represents the number of home runs. I want to know which team did the best, or the opposite, which one didn't do so well. As I scroll this table, it's a little hard to see who did the best. This is a perfect example. Instead of creating a summary table, let's represent this summary in a graph. Here I have a proc SG plot highlighted, again with the SAS dataset, SAS Help Period Baseball. I have two V-bar statements. That stands for vertical bar chart. I want to create a bar chart for team. Each team will be a different bar. The first V-bar statement is going to show me the summary of the number of runs for that team. In addition, I'm specifying a data label to be at the end of the bar. In the second V-bar team statement, I'm specifying that I want to see the total number of home runs. In addition, I'm specifying a bar width of 0.4, which is going to give me a skinnier bar, and I'm also adding that data label option. In addition to the proc SG plot step, we've started it with an ODS graphics statement. The first ODS graphic statement is specifying that we want our graph to be a width of 10 inches and our height to be 4 inches. At the end of the step, we have specified to reset those ODS graphics options. Here is the result of the proc SG plot step. I see my graph. I see blue bars and I see red bars. The blue bars represents the total number of runs for that team. The red bars represent the total number of home runs for the team. It's very easy now to see who did the best. If we look at the blue bars, New York has the most runs at 1,459. Second place would go to Chicago at 1,170. If we look at which team has the lowest number of runs, that's going to go to Atlanta. As far as home runs go, no surprise, New York and Chicago are at the top of the list. But if we look at which team has the fewest home runs, that's going to go to St. Louis. The purpose of working through this scenario was to give you motivation of why to do data visualization. At times, it is just easier to understand your data if it is in a graph. Now that we've seen an example of representing your data in graphical form, let me formally introduce myself. My name is Michelle Inser, and I have been teaching SAS classes for over 20 years. One of my favorite SAS topics to teach is ODS graphics. I like to show people how, with a little bit of code, you can get a graph. And with a little bit of persistence, you can get that graph looking the way you want. Today's presentation is about SG procedures, which is part of ODS graphics. Before I say anything more about SG procedures, I want to give a little background about creating graphs in SAS. You have options. For example, if you use Enterprise Guide or SAS Studio, you can use point-and-click tasks to create graphs. Another option, you can use SAS Visual Analytics, an interactive application for reporting, data exploration, and analytics. But maybe you don't want to do point and click. Maybe you are a SAS programmer and you want to write code. If that is the case, you really have two options, SAS Graph or ODS Graphics. SAS Graph has been around a long time, as long as I have been using SAS. SAS Graph is considered device-based and you must have a license for that product. You are using SAS Graph if you use a graphing procedure that starts with the letter G, such as ProcGChart or gplot or gmap or greplay or so on. ODS Graphics is newer but has been around since SAS 9.2. All you need is base SAS to use ODS Graphics. The technique is template-based, meaning behind the scenes the graph template language is being used. You are using ODS Graphics if you use a graphing procedure that starts with the letter SG, such as ProcSGPlot, like we looked at in the last demo. If you are new to writing graph code, I strongly suggest you use ODS Graphics due to the straightforward nature of the concepts and syntax. For the remainder of this presentation, I want to focus on the 5 SG procedures used for creating specific graph types. The procedures that I will talk about today are SGPlot, SGPanel, SGScatter, SGPy, and SGMap. To cover these procedures, I will go to my SAS Studio session and I will submit proc steps. I will share with you the purpose of the procedures and the syntax that is needed. As I demonstrate the procedures, realize I will be using SAS help datasets. What that means is any of the syntax I show you, you can enter into your SAS session, whether that is SAS Studio, Enterprise Guide, or windowing environment. Feel free to pause the recording as we go along to give yourself plenty of time to practice. I am back in my SAS Studio session, and I want to start with us looking at the syntax of ProcSGPlot in more detail. SGPlot is the most common of the SG procedures. SGPlot is used to create single-cell graphs. Within the one cell, you can create one plot or you can overlay numerous plots. Let's look at how simple it is to create a graph. I need a proc statement and I need a run statement. Between these two statements, at a minimum, I need one plot statement. I am going to add a VBAR statement for team. Running that simple proc step produced this bar chart. I see a bar for every team. That bar represents the number of players for that team. I can always add syntax to a plot statement. In this case, I've added a / to specify options follow. Now what I want, instead of a frequency of the number of players, I want to sum up the number of runs. Notice the difference. When you look at the y-axis, you see the runs for 1986 versus a frequency. I've added more options. For the fill of my bars, I want the fill attributes to have a color of Dodger blue. I do not want there to be an outline around each bar. I want there to be a data label at the end of the bars. That data label will represent the sum of the number of runs. And then for the data label attributes, I want the weight to be bold. It's obvious to see the change. I got Dodger blue for the color of the bars, no black outline around the bars, and at the end of each bar, I see a data label. That data label represents the total number of runs for that team. That number is in bold. I have added a second VBAR statement. This VBAR statement will overlay the initial VBAR statement. For this one, we are representing bars for the number of home runs. The fill color of these bars is going to be sandy brown. If you wonder what colors you can specify, you can always do a search on web colors, and web colors is one possible method for specifying colors. The bar width equals 0.4. This is a number between 0 and 1. The closer to 0, the skinnier the bar. Again, no outline, data label, and data label adders with a weight of bold, but the color of the text is going to be white. Now we see sandy brown bars on top of our Dodger blue bars. There's less home runs than there are runs. Notice the white text for the data label. It would be nice if I changed the size of this graph. Before the proc SGPlot step, we've added the ODS graphics statement. After the /, we have specified the width of 10 inches and a height of 4 inches. These are global options which will impact all SG procedures going forward until you reset. Well, that's what we did at the end of this procedure. We did an ODS graphics /reset. In addition to adding the ODS graphics statement, we've also added 2 title statements and a footnote statement. You now see a wider graph. Notice the titles: 1986 baseball season, total runs and home runs per team. In addition, there is a footnote that is right justified. You'll notice what are we doing to get our graph is we just add a little syntax, a little pieces at a time. We started real simple with a statement, and we keep adding more statements, keep adding more options. There's even more for us to do. For example, we might want to change attributes for our axis. Maybe change the labels or the values of the scale. Look at the y-axis. Right now, our scale is going from 0 to 1500, incrementing by 250. Within the proc SGPlot step, I have added an x-axis statement and a y-axis statement. For each axis statement, we have changed the label for the axis. In addition, for the y-axis, we are specifying that the values should start at 0, go to 1,600, and increment by 200. In addition, we are specifying that we want minor tick marks, 1 minor tick mark between every major tick mark. Notice the difference. We see different labels, and for the scale of the y-axis, it starts at 0, goes to 1,600, incrementing by 200. Next, let's take this legend and change the location. A key legend statement has been added. The legend will now appear inside the axis area and will be positioned in the top right. You can definitely see the location of the legend has changed. This program has been a good example. We started simple. We had a proc statement and a run statement. We started off by adding a VBAR statement. That statement was real simple, but we added options. Then we added more statements, other plot statements, axis statements, key legend statement. In addition, we used global statements such as title, footnote, and ODS graphics. It didn't take much to get a graph, but definitely more syntax was needed to get the graph looking the way we wanted. This is just one example of using proc SGPlot. Next, I want to show you additional proc SGPlot steps. Within this program, what I want to show you is different plot statements, showing you the different types of plots that you can create. Starting off, I have 2 proc SGPlot statements that are referencing the dataset SAS-HELP period baseball. Both steps include a where statement where we are subsetting where position is in first base, second base, third base, or shortstop. In the first step, instead of a VBAR statement, we are using HBAR, horizontal bar chart. For the horizontal bar chart, we will get a bar for each position. In addition, we have specified options. We will group the bars by league. Those bars will be clustered next to each other, and the length of the bar will represent the mean of salary. In the second PROC-SG plot step, we have a V-box for salary. We want a vertical box plot representing salary. In addition, we want a different box per each category of position. Running these two steps will produce two graphs. In the first graph, we see the horizontal bar chart for each position. The red bar represents the National League, and the blue bar represents the American League. The length of each bar represents the average salary per each position. If I scroll down, I can see the box plot. With the box plot, what we see is a box. That represents from the 25th percentile to the 75th percentile. Within the box, we see a diamond and a line, which represents our mean in the median. In addition, we have whiskers to our box, and beyond the whiskers, we have outliers. What we can tell from this box plot is that first basemen have a wider range of salary. Looking at a couple more steps, this time using the SassHelp table of cars. In the first PROC-SG plot, we are using SassHelp.cars with the histogram statement and two density statements. We want a histogram of the weight of the cars, and we want each bin to be labeled. On top of that histogram, we want two density curves. The first density curve is going to be a normal density curve, and the second is going to be a kernel. Versus in the second PROC-SG plot for SassHelp.cars, we are using the V-line statement. We want a line plot. On the x-axis, we are using the type variable. On the y-axis, we want to see the mean of MPG city and also the MPG highway. The y-axis is going to be our response axis. It's on the response axis that we will be able to see the miles per gallon for city and highway, and it's the average that we are looking at. Here we see the histogram for SassHelp.cars. It's a histogram for the weight variable. Then on the histogram, we got the normal density curve and the kernel density curve. Versus the PROC-SG plot that created the two line plots, this was using the two V-line statements. The blue line represents the miles per gallon for city, and the red line represents the miles per gallon of highway. Definitely the type of hybrid has higher numbers. Next, I want to show you 3 examples using SassHelp.class as the dataset. In the first example, we're going to do a band plot. For the band plot, our x-axis is height, and we want to create a shaded area from a lower value of 70 to an upper value of 120. Then on top of the band plot, we are going to put the scatter plot where we show on the x-axis height and the y-axis weight. Instead of doing something like a scatter, you can do a bubble where you have an X and a Y, but instead of getting the same sized markers, what we have is a third argument called size. The size of the marker is going to be dependent upon the value of age. The higher the value of the age, the bigger the bubble. Another statement that follows along with the syntax of an X equals Y equals is a reg statement. This is for regression. We want to do a regression. By default, we're going to do linear regression between height and weight. In addition, we want confidence limits of the mean predicted values in the individual predicted values. Here, the first graph we see is the band. It's a shaded area from 70 to 120. On top of that, we put the scatter. The band can be useful because that might be our target range for the weight. Second, I see the bubble. Each marker represents a given height and weight for a student. The difference is the size of the bubbles are different because the bigger the bubble, the higher the age. And the last one for SassHelp.class shows a regression between height and weight. The shaded blue area represents the 95% confidence limits for the CLM, and the dashed lines is for the confidence limits of the individual predicted values. Next, I want to show you 3 more examples. In the first one, we're using the dataset SASHELP period HART. In this one, we're doing a heat map. Heat map syntax is very similar to something like the regression or the scatter, where you do an x equals and a y equals. In this case, we're using the weight and the cholesterol. Then we are switching datasets and we're going to SASHELP period stocks. In the first proc step, we have a where statement where we are subsetting for stock equals IBM and the year of date equals 2005. In that proc SG plot, we are looking at a step statement. X is equal to the variable date and Y is equal to the close price of that stock. Versus in the last step that's highlighted, instead of using a step statement on SASHELP.stocks, we are using a high-low. For each date that we have in the dataset, we want to draw a line from the highest price of the stock to the lowest price of the stock. I got 3 graphs to show you. This first one is the one that is coming from the heat map. We have a heat map for weight and cholesterol. The more observations that we have for a given weight and cholesterol, a different color we will see. For example, the higher the frequency is represented with the red color. Here is an example of a step plot. In this case, we are connecting the closing prices, not a direct connecting the dots, but instead a stair step. In this graph, we're using that stock data, but again, for a given date, we are showing the stock price, the low value to the high value. At this point, I've shown you numerous different plot statements that you can use with ProcSGPlot. This is just some of them. It is by no means all of the different plot types. What I wanted to show you is how simple it is to get a graph created. Just add that one plot statement between the proc and the run. I kept my plot statements fairly simple. I didn't add a lot of options. But just like I showed you in the last demo, there's a lot that you can add to a proc step. The same applies to these plot types. Look at this ProcSGPlot. I took that last example that we were using with high-low, and I've added a lot more syntax. If you look on the plot statement itself, I have my X, my high, my low, but then I've specified options. I want to label my low and high ends. I want the low and the high ends to be serif or like a T. I want to have tick marks that show the open value and the closed value. I specify a color response, so the color of my lines is going to represent the quantity of value. The color model that I'm using is a color scale between 3 different RGB colors. In addition, I've specified label attributes and line attributes. In addition, we've specified axis statements with the x-axis and the y-axis statements. On those statements, we specified things such as value adders, what we want to display, our label adders, whether we want there to be minor tick marks and grid lines, and what those grid attributes should look like. Last statement we added inside this proc step is the gradient legend. The gradient legend goes back to the color response of volume and the color of model. That gradient legend is going to be positioned at the bottom with no border and title attributes. Let's compare the difference. Here is the example of the ProcSGPlot with nothing more than a very simple high-low. If I scroll down, that last example that I showed you with all of the additional statements and options produced this result. So I'm still getting my high-low, but I got a label at the low end and the high end. It is serif endpoints, so you see that T. Within the line, you see tick marks, which represents the opening and the closing values. In addition, the color of each line is being represented by the volume value. The higher the volume, the darker the color. So the one with the highest volume was in April. That color response created the gradient legend that we see positioned at the bottom. Just to go back to that code one more time. That's a lot of syntax. That's a lot of options and statements. My suggestion to you is that you give this a try. You type this up one statement at a time, one option at a time to see the difference of what each item will do for you. Wow, your head might be spinning. That has been a lot of syntax for us to look at. What I want you to realize is if I'm coding with SG procedures, I'm constantly looking at documentation. I'm not expecting you to remember everything that you hear in this presentation, not expecting you to memorize it all. Documentation is at your fingertips. Use it. I could not live without my ODS graphics documentation. What you need to do is go to a search engine like Google. Put in ODS Graphics Suite. That is going to take you to the documentation. From there, there's numerous different pieces of documentation. What we are going to focus on is the ODS Graphics Procedures Guide. In that guide, you will find the documentation to all 5 of the procedures that we are looking at in this presentation. At this point, I've already gone to a web browser and did a search on ODS Graphics Suite. Here is the web page that it has taken me to, and this is the documentation page for the ODS Graphics Suite. Later in this presentation, I will supply you with the link. If I scroll through this web page, I see documentation, and this is the SAS ODS Graphics Suite in SAS Viya. I see an overview section, SAS ODS Graphics Procedures, a mapping section, graph template language, related documentations, and example and resources. If you want to look at the documentation for something other than SAS Viya, you can go down below where it says previous versions, and you can pick your version of SAS 9. Let me scroll back up. I have been showing you SG procedures. It's right here in the SAS ODS Graphics Procedures Guide that I can get to the documentation of SGplot, but I can also get to the documentation of SGpanel, SGscatter, and SGPie. If I'm interested in getting to the documentation of SGmap, I need to go a little further down to the SAS graph and base SAS mapping reference. For now, since we just talked about Proc SGplot, let me click on the ODS Graphics Procedures Guide. Here is the documentation. If I scroll down, I can see the section of the procedures, and I see what SG procedures are included in this guide. Notice you will see SGplot procedure. If I click on this link, I will see all of the different syntax that I can include in this procedure. If I scroll through the SGplot procedure page, there are numerous plot statements that can be included. In addition, some of these are plot statements, but additional statements are appearance statements. For example, we looked at the VBAR statement. If I want to find out what's available in the VBAR, I could click this link and see all of the different options available. In addition to the VBAR, we looked at other statements such as x-axis, y-axis, and key legend. Another nice thing about the documentation is the documentation is broken up by syntax, overview, concepts, and examples. So much good information at your fingertips. Make sure you check out this documentation. Next, let's look at the Proc SGpanel and the Proc SGscatter steps. These procedures are similar in the fact that they create multi-cell graphs. SGpanel is based on classification variables. If you know SGplot, this procedure is simple because it uses much of the same syntax. The biggest difference is the addition of the panel by statement. Let's start off by comparing SGplot to SGpanel. In this Proc SGplot step, I have one plot statement, a VBAR statement. Compare that to this Proc SGpanel step, we got the exact same VBAR statement. The syntax that's different is that we have a panel by statement. Instead of creating one cell with one bar chart, we want a cell per each type of car. The layout that is used automatically with the panel by statement is the layout of panel. I'm going to run both of these steps. The first graph that we see is from SGPlot. It is a single cell where we are seeing the average manufacturer suggested retail price for each region. Compare that to the second graph. In the second graph, we had a panel by statement for type. Each type is a different cell. So now we get multiple bar charts. That is what SGPanel is. It's creating multi-cells where a different percentage of the population is represented in each one of the cells. Let me show you a couple other examples with Proc SGPanel. On the panel by statement, earlier we specified one variable type and it was using the default layout of panel. On this panel by statement, we are specifying type and origin with a layout of lattice. In each cell, we are wanting to see on the x-axis horsepower and on the y-axis MSRP. Here is the result, multiple cells. The columns represent the different types. We have a type of SUV, a type of sedan, and a type of sports. Whereas the rows represents the different origin. So the first row is for origin of Asia, second row is for origin of Europe, and the third is for USA. With SGPanel, you can easily compare plots per different panel by variables. Just to show you, you can go pretty simple with your syntax, or we can add to that syntax. For example, the syntax that we already know about the regression statement that we can use with SGPlot, we can use that with SGPanel. In addition, there's other statements that we might want to add. Instead of the x-axis and the y-axis statement, SGPanel actually uses the row axis and the call axis statements. In this example, we have specified the row axis to show the values 0 to 125,000 incrementing by 25,000. Here is the result of that last Proc SGPanel step. We can notice the difference for the row axis. It's 0 to 125,000. In addition, our regression looks different because we've added options such as CLM, CLI, and marker adders. What I want you to realize about Proc SGPanel, each cell has the same axis represented. The x-axis represents horsepower, the y-axis represents MSRP. So that's what Proc SGPanel is all about. Within one cell, you will get that x and y axis, but you will see the same x and y axis in every cell. Moving on to the SGScatter procedure, which also creates multi-cell graphs. Whereas SGPanel created multiple cells with each cell containing the same x-axis and the same y-axis across all cells, SGScatter can use different axes for each cell. SGScatter is limited to creating scatter-type plots, and there are only 3 plot statements available with this procedure. Here you see 3 proc steps. With the Proc SGScatter, the first one has a plot statement, the second has a compare statement, and the third has a matrix statement. Let's look at the plot statement first. For this plot statement, we want 2 cells. In the first cell, we want the y-axis to be MPG highway and the x-axis to be horsepower. In the second cell, we want MSRP as the y-axis and invoice as the x-axis. Here is the result. What I want you to see is for these cells, we have completely different axes being represented. First cell is MPG in horsepower. Second cell is MSRP in invoice. That was not the case with SG panel. In the second example, with the compare statement, in this case, what we are saying is that the y-axis of MSRP is going to be shared with two cells. In the first cell, our x-axis will be MPG highway. Our second cell, the x-axis will be horsepower. Again, MSRP on the y-axis is shared for both of those cells. Here is the result. Two different x-axes for our two different cells, but this y-axis of MSRP applies to cell 1, but it also applies to cell 2. The last example of proc SG scatter is using the matrix statement. With the matrix statement, you just specify variables. In this case, the matrix statement has 3 variables specified: MPG highway, horsepower, and MSRP. Those 3 variables will make up 3 columns and 3 rows. In addition, we have specified in the diagonal we want there to be a histogram and a normal density curve. Look at the result. First column is MPG, second column is horsepower, third column is MSRP. As far as the rows, those 3 columns are used. You'll notice in the diagonals we see histogram. The first histogram is for MPG, the second is for horsepower, and the third is for MSRP. Within a given cell, we can see what the axis represents. So this second cell here represents horsepower on the x-axis and MPG highway on the y-axis. This matrix statement is a quick, easy way to refer to numeric variables and see their relationship within a graph scatter plot. To conclude this demo, remember SG panel and SG scatter are similar in the case that they both create multi-cell plots. Next, I have a couple more SG procedures that I want to show you: SGPy and SGMap. SGPy came about in SAS 9.4 Maintenance 6 as pre-production, meaning SAS is still developing the procedure, but feel free to experiment with it. SGMap came about as production in SAS 9.4 Maintenance 5. Looking at an example of proc SGPy. In this example, we are referring to sashelp.baseball. We have a pie statement. We want to see a pie slice per each league value. In this case, without specifying statistics, the pie slice will represent the number of observations with that value of league. What we can see as a result: the American League has 175 players, where the National League has 147 players. Instead of getting a pie chart on frequency, you may want to specify a response variable. In this example, we have specified on our pie statement after the / response equals in runs. We want to see the sum of the number of runs per each league. In addition, we've added a format statement so that the number of runs will be displayed with commas. In this result, we see that the National League has 7,053 runs compared to the American League that has 9,761. Not only can proc SGPy create pie charts, they can also create a donut chart. A donut chart is a pie chart with a hole in the middle. We will get a donut for league, looking at the sum of the number of runs, and we have specified the whole label option where we will specify the text of number of runs within the donut. The result of the donut chart is just a variation of the pie chart. Let's finish up this demo by looking at proc SGMap using the dataset of SASHELP period quakes. In these examples of proc SGMap, I'm using the option Plot Data and referring to my SASHELP dataset. I'm also subsetting the data so that I'm only going to get the earthquakes from the United States that has a magnitude greater than 5. Within the PROC-SG map step, I need to specify the map that I want to use. I'm showing you 2 examples. You can use OpenStreetMap, and it's as simple as just saying OpenStreetMap semicolon, or you can use Esri Maps. If you use Esri Maps, you will need to specify URL equals and specify the Esri map that you want to use. If I scroll to the right, here's the URL for me to be able to use the Esri map called World Dark Gray Base. In both of these procedures, we are specifying the same bubble statement. We want to plot the X of the longitude value, the Y of the latitude value, and the size of the magnitude value. In order for you to use PROC-SG map, you need to have a data set that has coordinates in it. Well, if you go check out sashelp.quakes, you will see that there is a longitude and a latitude variable in the data set. So for each earthquake, it will go to that latitude and longitude value and display a marker symbol. But it's not just a marker symbol because instead of the scatter statement, we are using the bubble statement. With the bubble statement, we are saying where it's marking the earthquake, we want the size of that earthquake to be represented based off the magnitude variable. So the higher the magnitude, the bigger the bubble. Let's compare the result of the 2 PROC-SG maps. In the first graph that I see, this is an example of OpenStreetMap. So OpenStreetMap is used to create a map of the United States. On that map, I have these bubbles that represent the earthquakes. Again, the size of the bubble is dependent upon the magnitude. The higher the magnitude of the earthquake, the bigger the bubble. You'll notice the majority of the earthquakes in the United States appears on the West Coast. Instead of using OpenStreetMap, I can use Esri Maps. In this case, I'm using the dark gray map of Esri. In this case, you see the exact same bubbles on top of a map. The map just happens to look different. The 2 examples that I showed you at PROC-SG map was just enough to get started. It's important to understand for PROC-SG map to work for you, you do need data that has coordinates in it such as the latitude and the longitude. You might be saying, well, I have data, but I don't have that information. Well, there's numerous ways to go about getting coordinate information. For example, SAS has a procedure called PROC Geocode that can be useful for getting coordinates based off of your data. This is just a start. At this point, we've had a quick look at 5 SG procedures. In this demo, it was SGPy and SGMap. The previous demo was SGPanel and SGScatter, and earlier in this presentation was a good bit about SGPlot. I have shown simple examples, but there is so much more to learn. Earlier in the presentation, I mentioned SAS documentation. Again, I want to mention it. The first link on this slide is the link that will take you to the ODS Graphics Suite documentation page. Be sure to check out this documentation page. There's a lot of good documentation reference guides, including the ODS Graphics Procedures Guide. In addition, on that page, you can get to other ODS Graphics resources, such as the Graphically Speaking blog, one of my favorite blogs showing how you can get creative with ODS Graphics. Another resource that I tend to use for ODS Graphics is the SAS Communities website. If you go to communities.sas.com, there is a community specifically to creating graphs. I go here all the time to see questions that other people have asked and also to ask questions that I might have. In addition, if you're interested in a SAS book, go out to this support.sas.com/en/books link. Do a search for clinical graphs. You will see 2 different books come up. I really enjoy browsing through those books because it shows you the creativity of the graphs that you can create with ODS graphics. If you are interested in attending a class on ODS graphics, do check out our SAS education course that is available from the final link. To conclude this presentation, I want to thank you for attending and learning more about visualizing your data with SG procedures. Remember, start simple to get your graph created. Then spend the additional time adding options and statements to get the graph looking the way you want. Don't forget, use your documentation. It's all right there at your fingertips. Thanks.